What's up, welcome to Pumping Code! My name is Puria Izadi, and what if I told you that the Chinese AI startup DeepSeek just did something that no one could do over the past decades, and they reduced AI training instability from 3000x to just 1.6. And they just did it with math from 1967. Every AI model that you have heard about, like GPT, Llama, Nova, Claude, they all use the same trick, which is called residual connections. Super simple idea. So when data flows to a neural network layer, you just keep also the initial input you send to it, and then when the result comes out of the layer, you just add them up together. Think of it with this metaphor. So either when your signal is now entering the next step, it can either take the highway lane and skip the layer or go through it. So this is a great approach, but it has one issue. One lane isn't always enough. So that was the idea to bring in hyper connections. So researchers tried out something new. Why one lane? Why not four? It sounds great, right? And it worked. So the models got better, you could scale them, train bigger models with higher accuracy. But now there is one thing. When you work with residual connections, they have an issue during the training of vanishing gradients. And this leads to an effect which actually breaks your complete training flow. And by adding more residual connections in parallel, to stay with our highway metaphor, so 4 lanes instead of 1, actually this effect becomes even bigger. So more chaos to handle. So the very thing that actually made it powerful, made it so unstable, so that it was actually unusable. Everybody knew it, but no one didn't really touch it or fix it until DeepSeek came in end of last year. So right before New Year's Eve, DeepSeek dropped a new research paper, and it brought such an elegant solution to that problem. Their approach: don't get rid of the extra lanes because we need them, but just add guardrails to make them more stable. So they forced this residual mixing process to follow one specific rule. It's called Doubly stochastic matrices. Sounds complicated, but wait, it's not. So picture 4 glasses of water. You can now take water and pour into each of them some liquid. Now there is one specific rule. The total amount of water that you have stays always the same. So you have just one bottle of water and then you distribute it over all 4 glasses. And that's also the same for these multiple lanes in our residual connections. The total amount of signal strength stays the same. With that, even if specific signals are stronger on specific lanes, the total amount of energy stays the same. And with that, we don't have the chaos anymore. No spikes, no breaking of our training process. So now, instead of glasses of water, imagine matrices with rows and columns. So now what happens is, in this approach, each row sums up to 1. Each column also sums up to 1. So with that, we have everything under control. So no more gradient vanishing. Now this is the wild part. The mathematics behind this is from 1967, from 2 mathematicians called Sinkhorn and Knopp. So basically how this works is normalize the rows, normalize the columns, do this multiple times, up to 20 times for example, and that's it, done. So does it work? Well, we see the evidence in the DeepSeek research paper. They call it manifold hyperconnections. And now when we look at the chart, we'll see now how much stronger the signal stability is. So the performance even of the LLMs got much better, and we can see that over multiple benchmarks that you can see here in this figure. And you might be asking yourself, well, still the model is becoming slightly bigger with these MHC residual connections. And that's true. But now, when we look at the training cost, it's just around 6% higher than previously. So basically for what you get, this is not a lot. And also DeepSeek tested this with multiple model sizes. So they tried out 3 billion size models, 9 billion size models, or even 27 billion size models. Also what got my attention is that when you look at the research paper, the author list includes the CEO of DeepSeek. So this is a super important paper for them and for the industry. So this is really hinting the next generation model from DeepSeek, most probably the R2. So what does this mean? Well, in action this means they are training definitely models above 100 billions, most probably even a 1 trillion size model, and they're going to use that as the main model, the big teacher model, and distill smaller models from it. In any case, the big end result of this is that actually DeepSeek is going to release models with much higher accuracies that we are seeing right now. And this is super exciting because they made this knowledge open source. So also other model providers are going to leverage this. So from an application developer, consumer perspective, this is super amazing. So the next gen models with MHC built in are going to train much much more smoother, and this smooth training process will lead to much higher accurate models. So this is a great news starting the year, and this is fully changing the training scaling law of LLMs. So this was manifold hyperconnections, a new approach that makes training AI at scale stable. And if you like this video, hit subscribe and see you the next time when it's about AI and AWS. This is Pumping Code.